5 நிமிஷம் இருக்கு. முடிச்சிடணும். So good morning. Good morning everyone. So today we will see about the development of surfaces. Myself, Dr. Jay Balaji, HOD Mechanical, SRM Madurai College of Engineering Technology. So here, development is the graphical method obtaining area surfaces of a solid. So here the solid is open completely on the plane and the surface of the solid is to be developed. For example, we will take prism. Prism is made up of some number of rectangles and one side will be a height and bottom side will be the base. So 2 hexagon or pentagon and followed by the some rectangles. For example, hexagonal prism, so there will be 6 rectangles and for pentagonal prism there will be 5 rectangles. For a cylinder, it is made up of one rectangle at the middle and top and bottom will be the circle. And pyramid made up of, for example, pentagonal pyramid, it will made up of 5 triangles and hexagonal pyramid made up of 6 triangles and at the base hexagon. So there are different methods used to develop the surface. First one is parallel line development. It is used for prism and cylinders. And radial line development, it is used for pyramids and cones. Here the difference is, here there is a true length and slant edge at the radius, but in the parallel line development, so there will be horizontal top and bottom, there will be the pentagon or hexagon. So first let us see the parallel line development. This method is employed to develop the surface of prism and cylinders. 2 parallel lines called stretchout lines are drawn from the 2 ends of the solids and lateral surfaces are located between this line. So here we will see the example of a cube. So it has 6 faces. So 6 square compiled a cube. So prism. So after propagating this prism, there are 6 surfaces. Here we are seeing the square prism. ABCD is the rectangular surface and E and that is called lateral surfaces, and at the top and bottom E and F is called the bottom and top area. Here, since it is a square prism, square is there. For pentagon or hexagon, it is replaced by the respective profile. So this is the construction of development of prism of a pentagon prism or hexagonal prism. This is the formula we are seeing. So for prism, base length will be S, and so here we are seeing the pentagonal prism. So base and top there will be 2 pentagon. So there will be base length will be the S and H will be the height. So in the question they will give these 2 parameters. We have to construct a pentagonal prism followed by the development of surfaces. With respect to this cylinder, D is the height, D is diameter and H is the height. So when we are projecting this development of surfaces, the length will be the pi d. This method is called parallel line development method used for prism and cylinders. So we will go to the problem directly. Problem number 1. A pentagonal prism 30 mm base side and 50 mm axis is standing on HP at its base with one side of the base is perpendicular to VP. It is cut by a sectional plane inclined 45 degree to HP through the midpoint of the axis. Draw the front view, sectional top view, sectional side view. Also draw the true shape of the section and development of surfaces. This is the question. So first we are constructing a pentagonal prism with respect to 30 mm base side, 50 mm axis is standing on HP. Standing on HP means, so prism, the height will be coming in the front view and the pentagonal profile will be at the top view. And one side of the base is perpendicular to VP. So here, one side of the base is perpendicular to VP means, so CD, then profile, the line CD is perpendicular to XY axis. So now we are constructing a pentagonal prism. So ABCDE is the pentagonal profile and the height will be at the front view. So now we are drawing the side view also. Now a section plane 45 degree to HP through the passing through the midpoint of axis. So now we are dividing this line BE into two equal parts. Then we are drawing a line of a 45 degree to XY axis. So cut section will be coming at the from the XY axis. A dash, comma B dash, comma C dash, comma D dash, and E dash will be the sectional plane of the in the front view. So this is the axis. Then we are now we are drawing the development of surfaces. So as I told earlier, the development of surface, we have to draw the height of the prism. Prism will be the height is now it is 50 mm axis. Then length will be the, so since we are having 5-sided faces, so 5 into 30, 150 mm length. Then we have to divide into AB. AB is equal to 30, BC is 30, and CD 30, and DE is 30, and E also 30. So we are dividing this into 5 equal parts, and height is also 50 mm. So now we have to locate this A, B, C, D, E, and once again A. So now we have to project A dash to the developed area. Then the point out as capital A. Then project B dash to the developed area and project as capital B. Then project C dash to developed area and point out capital C. So similarly D and E. So this is the development of the true surface, developed surface. Then we will see the true surface. So when true surface, we have to draw the section plane XY axis parallel to the section plane. That name it as X1 and Y1. Draw a line perpendicular to the section plane. So from A dash and B dash, similarly CD and E. Now from the coming to the top view, from the XY axis, measure the distance from A, then project from X1 to A. Then for projecting B, measure the distance from X, Y, B, then projecting up to in the X1 and Y1 plane. So that will be the capital B. So similarly, draw for C, D and E. Now join A, B, C, D, E. So this will be the true shape of the section. So this is the developed surface of a prism. So another, we will see the one cylinder area. The question is, draw the development of the lateral surface of the lower portion of a cylinder of diameter 50 mm and axis 70 mm when sectioned by a plane 40 degree to HP and perpendicular to VP bisecting the axis. So first, since the cylinder is in the draw the front view at the above the XY axis, so it will be the rectangle, and top view at the bottom, that will be the circle. So divide this circle into 8 equal parts. Name it as A, B, C, D, E, and at the bottom UVW of PQRS TUVW. So now similarly draw the front view. So the front view bottom surface, it will come A dash, B dash, C dash, and at the top PQRST up to W. So now similarly it is similar to the prism. Now we come into the section plane. The section plane is given that it is inclined 40 degree to HP and perpendicular to VP. So the section plane will be at the coming to the top view. So from the XY axis, draw a line. First mark at the axis point, bisect the axis. Then name it as R and RV and CG. So this is the axis which is overlapping to the cylinder's line. Now divide this into, that is now it is 75 up to take the point at 35 mm. and mark the point and draw a line 40 degree to HP, that is XY axis. Now name this section plane as 1, 2, 3, 4, 5, 6, 7, 8. For example, A dash P dash, name it as 1 dash, B dash Q dash, name it as 2 dash. So up to 8 dash. So now the section plane is completed. The bottom portion of the section plane is darkened, and the top portion is which is removed by the section plane, which is in the light in color. Now we have to draw the development of surfaces for the cylinder. As I told earlier, the length will be the pi d. So pi into the diameter 50. So 157. Then the height will be the same as the height of the cylinder. So draw a rectangle. So divide this into 8 equal parts. And name it as at the bottom. There we have named as A dash. Now here A dash, capital A, B, C, D, E, F, G, H and A. And at the top, as usual, P, Q, R, S, T, U, V, W and P. So this is the developed surface. Now we have to mark the section plane. So project the line from 1 dash of the front view to the developed surface, and which will the point where it meet PA will be the point number 1. Second, project the line from 2 dash and to the developed surface, the point where it meet BQ will be 2. So similarly, draw 3, 4, 5, 6, 7, 8 and last P and 8 will be 1. So now join A, B, C, D, E, F, G, H, A and 1, 2, 3, 4, 5, 6, 7, 8 and darken this. So this is the development of the cylinder. So now coming to the cone and pyramid family, here it is one more parameter will come, it is called slant edge. So slant edge is different from axis. So slant edge will be inclined one and axis will be the straight from the center. So the theta, we have to, when we have to calculate theta, theta is equal to, for cone, R by L and into 360 degree, where R is the base circle radius and L is the slant height and S is the base. Now we will see the, for one example for pyramid. Now I am taking the square pyramid. Draw the development of the lateral surface of the square pyramid of side base 25 mm and height 50 mm, resting with its base on HP and the base of parallel to GP. So here, now draw the front and top view. So front view will be the triangle. For square prism, front view will be a triangle and the top view will be the square. So top view will be the 25 mm square, 25 mm and 25 mm, and front view will be the rectangle of 50 mm height. So in the top view, we have to cross the square A, B and CD since it is a pyramid. So now we have to construct these development surface of the pyramid. First take the point O, then draw a line A. The length should be equal to the true length of the slant edge. So true length of the slant edge will be the O dash A dash. So measure the length of the O dash A dash and draw the same length. From that, take the formula. The same formula, theta is equal to R by L into 360. Draw the angle. Then divide this into, from this we have to take the radius OA as a radius, draw an arc. Then from AB, make the take the length as 50 mm. Mark AB, it is equal to 25 mm. So that is the base edge. Then BC 25 mm, CD 25 and DA is also 25. So join AB, OA, OB, OC, OD and OA. So that is will be the true shape of the development surface. So we will see one more example of cone. A cone of 50 mm base dia and 70 mm axis is standing on its base on HP. It's cut by a section plane 45 degree inclined to HP through the base end of the generator. Draw the projection, section view, true shape of the section and development of surface of the remaining solid. So here we have to draw a circle of base 50 diameter, that is the top view of the cone. Then front view will be the 70 axis. So draw a line of 70 axis and draw a triangle which is the top view of the cone. Now we have to draw the true shape of this section, true shape and development of surface. So first we will draw the true shape. Now we have to come into the section plane. Section plane inclined to 45 degree to HP and base end of the generator. So from the base end generator, we have to draw a section plane at an angle of 45 degree. So here at the top you have marked the coordinates A, B, C, D, E, F, G, H, and at the front view will be A dash, B dash, C dash, similarly up to H dash. So here A dash, O dash, take it as point number 1, and B dash, C dash, take it as point number 2. Similarly up to H dash and F dash, H dash and O dash. So here now from the top view, from XY plane, from 2A, mark, find the point number 1, then mark it from X1 and Y1, that is your point, true shape of the section capital 1. Then from the top view A, B dash, XY to B, measure the distance, and from X1 and Y1 mark the point number 2. Similarly 3, 4, 5, 6, 7, 8. Now join 1, 2, 3, 4, 5, 6, 7, 8. So that is will be the true shape of the section. So coming to the development of surfaces of the cone, we have to take the formula theta is equal to R by L into 360 degree. So here R is given and L is given. Draw the find the angle theta. So that will be the A to A. Then take the radius of the slant edge of the cone. Measure the slant edge of, say that is O dash and A dash, and mark it as the radius of the cone. Now divide this angle theta into 8 equal parts. Name it as A, B, C, D, E, F, G, H, A. Then join from O dash, O to A, O to B, O to C, O to D, and O to E up to O to H and O to A. Now at OA, mark the point number 1 from the top view. Then O to B, mark point number 2 from the top view. O to C, from XY to C, mark the point number 3. So similarly up to H. So join all 1, 2, 3, 4, 5, 6, 7, 8 and A, B, C, D, E and darken the line. You will get the top, development of the cone. One more example, a regular hexagonal pyramid of side base 30 mm and height 60 mm is resting vertically on its base on HP, such that two sides of the base are perpendicular to VP. It is cut by a inclined plane 40 degree to HP and perpendicular to the VP. The cutting plane bisects the axis of the pyramid, obtain the development of the lateral surface of the truncated pyramid. So this is the example of hexagonal pyramid. So here the top view will be the hexagon and front view will be the triangle. So here the base 30 mm, first draw the hexagonal profile, then at the front view draw the triangle. So join at the bottom base, name it as PQRSTUV. So now draw coming to the front view, draw the section plane. The section plane is mentioned that it is inclined 40 degree to HP and perpendicular to VP. It bisects the axis of the pyramid. So from the axis is overlap with the line O dash and Q dash. Now measure that is 60. At 30, mark the point. Then from that point, draw a line 45 degree. That is your section plane. So this section planes will meet the O dash P dash at 1, O dash Q dash at 2 dash, O dash S R dash at 3 dash. Similarly up to 6 dash. So mark it as a section plane. Now drawing the development of the surfaces. First take the point O, then measure the slant edge of the front view O dash A dash and mark it as O dash P dash and mark it as OP. From OP, draw a OP as radius, draw an arc. From the arc, the base edge will be 30 mm. Mark it as PQ 30 mm, then QR 30 mm by your compass. RS 30 mm, ST 30 mm up to U. Join OP, OQ, OR, OS, OT and OU, OP. So at OP, go to the front view, mark the point number 1 through your compass and mark at OP, the point number will be the 1. Similarly, from the OQ, measure the distance from O dash and 2 dash, mark at the development of surfaces, the point will be 2 at OQ. Continue the process up to 3, 4, 5, 6 and 1. Join 1, 2, 3, 4, 5, 6, 1 and PQRST. So that is the development of surface of a pyramid. So this is the two family example. One is pyramid and one is prism. So these are some more examples. So I already explained clearly the angles and slant edges. Okay. Okay, thank you.